right? Pass right through each other. Yeah? So I'm thinking about this, like why doesn't it pass through? And of course the answer is there's a very simple thing called the Pauli exclusion principle. It says that the electrons on the outside of this solid object cannot occupy the same quantum state as the electrons in this one, and so we have solidness, right? Yeah? Okay. Now, so I start thinking to myself, and I start just doing what I do is a phase invariant time independent transform of the lepton energies, right? And I using general relativity, right? I redo the Hamiltonian transformation, right? And I get a phase invariant form of the Pauli exclusion principle, right? Which states that if I have a strong enough stasis field, right, I can use tachyon inversion itself. There's some risk of total time reversal here, okay? But I can use the tachyon inversion itself to stabilize those fields and have a solid object, such as a stapler, pass through another solid object, like a tape dispenser. Right? Just like, but it would be like this. It would come along and it would be like, and it would go right on through it, right? Right? Okay. Now, what I've got here, this is my transmogrifier. Okay. I've got some of the parts are up there, and then a lot of it, right? And and the problem is, and eventually I'm going to get, don't worry, I'm going to get the stapler to go through the tape dispenser. Right now it only works with objects that are identical. This one, right? Okay. And I know what you're saying. I should mark one like A and the other one B so we know that they don't just bounce off each other, right? But if I did that, they wouldn't be the same, right? Yeah, that would. I don't have quite the flux invariance for that, right? So, but I know what you're thinking, right? You guys, weren't born yesterday. Okay. So what I'm going to do is I'm actually going to send them into the tunnel with different velocities. Okay. So here's this guy going in the tunnel. This is my favorite application, right? A slow car in front of you inside a tunnel, and you're driving your Lamborghini, right? And you want to pass them, but you can't in the tunnel. So you hit a transmogrify button and go right through them. Watch this. Slow car ahead of you, right? Here comes a fast car. Woo! Fast car goes right on through slow car, right? Isn't that cool? Slow car going into the tunnel. Fast car goes right on through. Fast car goes right on through. Here comes a slow car. Right? You could even save money with your roads. You could have single lane roads and they just simply automatically transmogrify, right? Okay? So I'm going to send this guy in slow so you know it's not, right? Slow car going into the tunnel. Fast car. Oh, I did hear a noise there of the transmography. And there goes the slow car. See it? Right? Slow car going into the tunnel. Fast car. Fast car comes right on through. Slow car goes out that side. I think we need... Okay. I feel kind of bad. I kind of pulled the wool over your eyes. This is just a false box. It's just like... There's nothing in there, okay? Because see, what's going on here is that in a perfectly elastic collision, when the objects have the same mass, they simply trade velocities. Anybody who's played pool knows this, yes? In fact, I gave it away a little bit before, right? If an object's sitting still, if you hit a ball head on, right, with no top spin, head on like this, that's at rest, what does it do? The original ball stops, the other one moves, yeah? Don't we all know this? If you played pool, right? So didn't they just trade velocities? Yeah, and it works in all situations, right? This guy's moving slow, this guy's going fast. Isn't that great? Yeah! Right? This guy's going slow, this guy goes fast. Doesn't that work? Isn't momentum conserved and energy? I love that. That's marvelous, right? Now to solve these things, all you do is you set up mv plus mv equals mv plus mv, and then you have to also set up 1 fmv squared plus 1 fmv squared equals 1 fmv squared plus 1 fmv squared. You could do it. It's a system of equations. It's not pretty. It's not fun, but we're not going to do that. So, okay, a little bit of applause for the tunnel of transmogrification. All right. Okay, so let's see. Yes, you can. All right. For my next demonstration, I've got, I know what it is. All right, here it is. Okay. First, though, a magic trick. I have a rubber ball. My rubber ball is a very bouncy ball. But if I hit it twice, it becomes not a bouncy ball. Twice again resets it. Amazing. Hit it again. And then if I hit it 4 times, it becomes 2 balls, one that's bouncy, one that's not. Or it was maybe 2 all along, right? Okay. This one is made of rubber. Okay. And the way it bounces is, of course, anything that bounces has to deform or store the energy as potential energy, right? Because they have to come to rest at some point, right? And then it has to turn it back. And it's not perfectly elastic because I drop it from here and it only comes up to here, right? The coefficient of restitution is like 60.6, 60% or something like that, right? This one, however, is made of rubber. A different kind of rubber, though, right? This rubber, when you distort it, it doesn't bounce back immediately. It bounces back slowly because it's made of different, slower rubber stuff. That was a pretty good explanation, wasn't it? Yeah? Okay. But it's a bit like the door closers on the door, right? The molecules can be quickly distorted and they only slowly go back. The door closer can be quickly opened and it only slowly comes back, so it's not a reversible thing. I'll pass these around, don't lose them, but you can, the one that doesn't bounce so well, you can stick your finger into it and you can feel it not spring back. This one, of course, feels like a normal rubber ball, right? It's like, oh yeah, it's different. Ooh. Okay. Now, the question is, and the question always is, what is better at knocking something over? Okay? Because we always want to know this, right? The police could use rubber bullets, which would bounce off a demonstrator, or they could use lead bullets, which would just sort of stick in them and have other effects, right? So, and I was going to have the Taunton police come in here at this point, just come storming in and start pelting you guys with rubber bullets, right? You wouldn't believe the red tape that the whole district, they're all like a safety and stuff like this, you know, and right? Okay, so I've got this demonstration. This guy's going to stand for the demonstrators, like, we want our rights, right? This guy will represent the lead bullets, right? This is going to hit them and stop, and this one's going to represent the rubber bullets, okay? Now, let's, which one should I do first? I think I'll do the lead bullet first. Which one's going to be better? Is it going to be better if you hit it and stop? Or is it going to be better to hit it and bounce off? How many think it's going to be better to bounce off as far as knocking it down? How many say it's going to be better to just hit it and stop? Most people, obviously, there's a great majority say it's better to hit and stop, isn't it? We don't even need to do that. We don't even need to do the demonstration, do we? Oh, okay. Oh, all right. So I'm going to do let's do this is the lead one, isn't it? This is the one that just hits and goes thud, yeah? All right, are we ready for this? So what I'm going to do is I'm going to fire it at different speeds, and the speed is just determined by how high I drop it from. Oh, the demonstrator's not even phased. Let's try a little higher. It's like, oh wait, that's cheating. Okay, hold on. Let's be scientific about this. Okay, how about a little higher, like this? This is going to work for sure, isn't it?
No.
It just barely worked, and it was nearly vertical, wasn't it? Or nearly horizontal. Let's try that again. Let's make sure we're like there, right? I've done this before. There we go. Yeah? So right about there is how high we've got to get the one that just stops when it hits, right? So now let's switch over to less lethal methods, right? All right. Here we go. We're hitting the same spot. We've got the same mass because we've stuck different masses in these things, right? Let's try that same height. See if it can knock it over. Ooh, that knocked it over. Let's try a little lower. Does that work? This is definitely lower, isn't it?
Yeah.
Ooh, that's working. Somehow bouncing is better, isn't it? There we go. I dropped it from there and it knocked it over. Why is it giving it more impact when it bounces off? Can somebody explain?
Energy transfer.
Don't think energy, think momentum. What is a bigger change in momentum? Is it bigger to hit something and stop? Or is it better to hit something and turn around and go backwards? Remember, momentum's a vector. Which is a bigger change of momentum? Hitting it and going backwards, isn't it?